This is questions 3 and 4 from exercise 4.2 in Project Maths 3A. So, in the questions we have to calculate to the nearest degree the angles marked with a letter. So we'll look at question 3 first. We've got a triangle where we've got sides marked 11 and 9 and an unknown angle marked B and a right angle marked here. So we have a right angle triangle, which means 11 is our hypotenuse, and in relation to B, 9 is the adjacent side. So the first thing we're going to do is we're going to put together a ratio, either sine, cos, or tan from this, and work from there. So we'll work with what we have. We've been given the adjacent side to the angle and the hypotenuse, and the ratio that uses adjacent and hypotenuse is cos. So the cos of B is equal to adjacent over hypotenuse, which is 9 over 11. And from there, that means that B is equal to cos inverse of 9 over 11. Which means, now for that we're going to have to go to our calculator. There's no other calculator that we have otherwise. So we go to our calculator, we press the shift button, we press the cos button, which will give us the cos inverse function that we need. And then we'll have an open bracket on our screen, and into that we're going to put in 9 over 11 by using the fraction button, obviously. And then we're going to just make sure we press right to get out of the fraction, close our bracket off, and press equals. And when we do that, we should get 35.0968. And there's a few other numbers, but since we're going for the nearest degree, we need it to the nearest whole number. So B is going to be equal to 35 degrees for that one, for question 3. Now let's look at question 4. Initially, question 4 looks like we've got the exact same setup as we have for question 3. We've got the same two sides marked, we have a right angle triangle. But this time, the angle that we're looking for is not in the same position. So we do not have the adjacent side and the hypotenuse this time. In relation to this angle theta that we have in question 4, we have the opposite side and the hypotenuse. Which means that this time we're able to say that the sine of the angle is equal to, and this time it's going to be 12 over 17, opposite over hypotenuse. And that will mean that the angle theta is going to be equal to sine inverse of 12 over 17. And again, we're going to go to our calculator for that, shift, sine key, put in our fraction, press equals, and we are going to get 44.90087 ... But we need it to the nearest degree, so we're going to round that. So our theta is equal to approximately 45 degrees. And that is that.